lot to say, so we better get started very, very rapidly. But not without me introducing him. So my name is Melanie Cooper. If you don't know me, I'm from over in the chemistry department. And I am actually the host for Ryan during his visit to Create. And I got to know Ryan at first when I was on the board on science education. And Ryan was a fellow there at the National Academy of Science. We got to talking one day at one of the board meetings, and he said that he was unhappy. He decided that his future wasn't in synthetic organic chemistry. He was doing a PhD at Scripps, and I said, well, come and see us at MSU, and maybe, maybe we can talk about you changing fields. And he did exactly that. He came, he visited. He actually stayed for 3 years as a postdoc in our chemistry education research group, and then went on taking a lot of funding with him to the University of Wisconsin, Madison. He's currently an assistant professor in the chemistry department there. And I hear he's going to give us quite a provocative talk today. So please welcome Ryan.
Thank you so much for the kind introduction and invitation, Melanie. It's kind of weird to be back here. I mean, I sat in this audience and watched many great Create seminars, and being on this side is a bit surreal. So it's wonderful to see so many friendly faces in the audience. I hope we can all have a productive existential crisis together. The title of my talk is Chemistry for Whom and for What Purpose? And this title is here because I've found these to be generative questions. When we think about the fact that tens of thousands of students are required to take chemistry courses to continue on to STEM majors and STEM-related careers, when we think about the sorts of reasoning these courses are meant to embody, we, I think, are obligated to make arguments about the general utility of that kind of reasoning. And so I'm going to probe a little bit into the characteristics of what reasoning that is useful in daily life might look like, and how or whether certain reform approaches are living up to that potential. Before I get going, Stacy Lowry-Bretz introduced me to doing the acknowledgements first so we don't rush them at the end. I think that's a lovely practice. I have a wonderful research group of 6 graduate students, and that's the dog, Joe, if you don't know him. There he is, he's living his best life. One of the really cool things about our group in Madison, really modeled after Melanie's engagement with Create, is that we get to do a lot of wonderful scholarly work with friends in School of Ed. And so Rosemary Russ on the top right and Katie Kirchgassler on the bottom right, both are faculty in School of Ed who we have joint projects with, and I find those discussions really, really enriching to the work that we're capable of doing. I often give talks in chemistry departments, and when I do so, I ask this as a beginning question. And I've asked this question enough times now that I think I can predict most types of answers that are likely to come up. So when I ask why so many should be mandated to take chemistry classes, some will answer, chemistry knowledge and skills are useful in daily life. The content of what you are learning will help you do things that you want to do later. Of course, you'll get that one sort of lone faculty member that says, some of our students will be chemists, and of course we owe it to those students to prepare them for success in those professional pursuits. Chemistry is cool, so thinking about matter interactions at the molecular scale can be a beautiful way to understand how and why things happen, and that way of mechanistic reasoning can give you tools to explain that are not accessible at other scales of interaction. And so that can be a fulfilling experience. This fourth one has to do with the notion that there will be ways of thinking in chemistry class that students will encounter that will also be helpful beyond the bounds of the classroom. And so I think the first and the fourth of these can go together, and we can say that a reason why many folks are required to take chemistry classes is that it is alleged chemistry knowledge and skills will be useful in daily life. Useful in daily life is one of these sort of squirrely phrases like critical thinking, which everyone has a different definition for. So I'm using my friend Noah Feinstein's definition here. And so the hope is that chemistry learning will help people solve personally meaningful problems in their lives, directly affect their material and social circumstances, shape their behavior, and inform their most significant and practical political decisions. Not determine, it's not like if you know about molecules you will vote X way, but it'll help out. That's the hope. So this sort of argument, that chemistry knowledge and skills are broadly useful beyond the bounds of professional practice, is an old argument. And I have a couple of fun quotes from the 60s. And so Morris in 64 is talking about how chemistry knowledge and skills are helpful in dealing with problems in a variety of grain sizes, individual problems, community problems, world problems. But my favorite quote is this one. In our democratic society, objective thinking based upon an understanding of the structure and interaction of matter leads to a better life and should therefore be part of the education for all. My point here, yeah, right, there we go. My point is not to pick these apart. You could, that's not what we're doing right now. My point is simply to say the useful and daily life argument is enduring and has been powerful. So, how do we use chemistry knowledge in daily life? I'm going to use a personal anecdote to illustrate facets of the science and technology studies literature that certainly extend beyond the experience I'm going to share. Remember articles like this a couple of years ago when everyone was like, you know, maybe cooking with gas in small unvented kitchens is not great. You can see there were 4 different linked articles to this New York Times article, and this article made claims such as when you cook with gas, you produce various nitrogen oxides. These build up to a level that might cause you problems if you're prone to respiratory irritation, and this happens fairly quickly. There were a number of peer-reviewed articles that were linked in this New York Times article. Here's one. And you can see that after about an hour of cooking with gas, especially in these enclosed kitchens, you're blowing above the EPA threshold for 100 parts per billion, indicated by the dotted orange line. And so this seems like it might be something that some folks would have to consider, especially if you have a gas stove in a small unvented kitchen. And I did. And so I was just reading the New York Times one morning, and I ran across this article and went, crap, do I need to worry about this? Now, you're probably thinking, oh, Ryan's a chemistry professor. He must know lots of stuff that will help him here. I bet he can model gas behavior. I bet he can say things about pi bonding. He probably also knows about like kind of how gas stoves work and things spreading out or concentrating. He probably knows stuff like that too. In addition to all this content, I bet Ryan knows stuff about what makes a persuasive or useful argument or explanation or model. These are different kinds of knowledge. The knowledge on the top, where we have it in yellow and green and orange and blue, this is conceptual or content knowledge. These are the skills and facts that are contained in the course, and getting students to reproduce skills and facts that are considered normative has often been a focus of chemistry and science education research. The knowledge on the bottom, well, this is meta-knowledge about what makes for a useful or persuasive argument or explanation. This sort of knowledge is referred to as epistemic knowledge. And a lot of folks have written really thoughtful papers on the nature of personal epistemologies. Clark Chin and colleagues more precisely define these epistemologies as systems of beliefs, tacit or explicit, about the nature of knowledge and the processes of knowing. This is a very long but very worthwhile read, and it was one of the optional papers in Christina's class that I took as a postdoc. You can slice ideas about knowing and learning in a variety of different ways. You can think about the goal animating knowledge construction. You can think about the source of useful knowledge. Where do you go for knowledge pieces that will help you out? You can think about justification. What are the criteria for a useful explanation or model? Why do we care about the big philosophy word? Often when I talk about epistemologies in chemistry departments, they're like, that word scares me. I took intro philosophy and I dimly remember that was in a book. Remember, I allegedly have lots of different kinds of knowledge about dealing with my unvented gas stove. I have procedural knowledge about mathematically modeling gas behavior. I have formal fact knowledge from school about things that have science words embedded in them. I have everyday experiential knowledge about sort of roughly how gas stoves work. I have generic schematic knowledge about things concentrating or spreading out. What epistemologies do is shape where you look for knowledge and what you try to do with it. So if my goal in talking about my gas stove was to sound sciencey, I'm going to call back to a time in which I've had to sound sciencey before, and I'm going to draw on knowledge and ways of knowing that have helped me sound sciencey in the past. You know when I've had to sound sciencey? School. And so I'll probably be predisposed to draw on knowledge sources that have been useful in navigating school. These are going to be more of the procedural or formal fact categories of knowledge. Now, if instead my goal is to construct an explanation or an argument that seems sensible to me, well, I've had to navigate more or less sensible arguments in lots of different contexts beyond those in the classroom, and so I may then have a broader swath of places that I look for knowledge. I might look at my everyday life. I might look at these more generic ideas about things concentrating or spreading out. I might be less reliant on using buzzwords in sentences. I pose to you which of those two goals seems more like something you would encounter in post-school daily life. In my particular case, I've been constructing knowledge in this context with my unvented gas stove because I don't really want to poison people or myself. I don't really want to make climate change worse by leaking a bunch of methane through sort of fittings that aren't quite tight enough in my gas line. I've been constructing knowledge while accumulating knowledge from sources I consider authoritative. These are both popular press, Times Post type places, as well as some peer-reviewed literature. I am not an atmospheric chemist. I don't consider myself an authority to look at peer-reviewed data without any context and come to reasonable conclusions. Knowledge is justified here by aligning with several sources that I consider trustworthy, and my partner and I crafted arguments about what, if anything, to do next. I will tell you what I did next, because if I don't, it is always the first question. We now have an induction range. It's great. Yay, induction. Because getting a fume hood in that ceiling wasn't going to happen. What hasn't been happening is that there was no answer key. This is actually a pretty complex phenomenon. Like, if you cook a lot of things that require a flame to sear, then you're probably going to look at venting your kitchen over buying an induction range. I got to decide to begin this journey when I read a Times article and it freaked me out, and also when to end it. And this was negotiated. It wasn't just me making decisions. My partner and I got together to co-construct reasonable arguments about what to do next. Chemistry knowledge was helpful because I had to appreciate that when I burn methane in an atmosphere that's largely nitrogen, it's reasonable to create these nitrogen dioxides, and those can sort of build up. But knowing more chemistry facts alone isn't actually going to get me out of my bind. If I talk with great precision about nitrogen-oxygen pi bonding, it still doesn't help me pick my stove. And so I and many others would argue that if we want to prepare people for post-school daily life, what we're after is not really some predetermined set of facts and skills. Instead, it is supporting students in being able to talk and think about useful ways to know and learn in contexts that would approximate scenarios they would encounter in post-school daily life. Messy context, where there's not one obvious right answer, and where science alone won't solve your problem. So let's take a look at a course that I have taught, which is a transformed course and has a lot of affordances, and see if the ways in which students felt they were able to construct and justify knowledge are, in principle, useful in daily life or not. And on the bottom, I want to acknowledge my coworkers. Is Kara here? Maybe she couldn't make it. So Kara Schwartz, who is there, actually works here in the new STEM building. She's a lab director. So she did some of this work. Kimberly DeGlopper over on the left, and also Rosemary Russ and Nicole Greco. So the ways in which we're thinking about these ideas related to knowing and learning align with a network model of epistemology. So we are considering these ideas about useful places to go for knowledge, useful aims and so forth, to be small-grained knowledge elements that are compiled in the moment in response to features of a context. There are not one set of best ways to know and learn. Useful ways to know and learn will depend on what it is you're looking to achieve. So sometimes you'll see in the nature of science literature that it is considered unsophisticated to take knowledge from an authority. I would posit you all do that when you look at your weather app and decide whether to bring an umbrella, and in fact that is a sensible way to navigate that particular challenge. There are multiple dimensions to epistemology, like aim, reliable, process, ideal. We'll talk a little about that, but not a lot. And one of the analytic challenges here is these ideas about knowing and learning are often unspoken and unconscious, and you get to infer them from behavior, which is fun. The context for this study is a reformed Organic Chemistry 1 course. This is an on-sequence course offered at our university. It's structured in a pretty typical kind of way, which is to say there are 3 50-minute lecture meetings. These are like 300-person stadium-style lectures. There's one 50-minute small group discussion where about 30 students will work together to predict, explain, and model chemical phenomena. Grades are determined with 4 high-stakes exams and 3 quizzes. I appreciate this is probably part of the problems we will come to, but that's what it is. I can tell you a little bit more about what's assessed and what a class looks like than simply the bullet points on the last slide. I think it's important that we consider the sorts of intellectual work that are credit earning in these classes. And I'm going to use a perspective you are all very familiar with to do so. And so when we're thinking about the way in which the focal course was reformed, I want to connect what we did to the National Academy's framework construct of 3-dimensional learning. So the goal in the focal class was for students to use powerful explanatory ideas like energy and bonding to engage in scientific sense-making practices that are meaningful and useful to professional scientists. These include modeling, argumentation, explanation, and the like. And both of these knowing and doing ways of interacting with course content are, of course, framed by cross-cutting lenses. So we might be after a causal explanation, a structure-function relationship, or looking for patterns in data. Again, this is all old hat to all of you. The ways in which we looked at our assessment items in the focal course also are familiar to many of folks in this room. We use the three-dimensional learning assessment protocol. This protocol works by taking a look at a particular assessment item and seeing whether that item meets a series of criteria. And so first, you would ask, does the item that I'm looking at have the potential to elicit evidence of student engagement in a scientific practice? An item would have this potential if it fulfills all these criteria. So it gives some sort of observable event in the world. It either gives a representation or asks students to construct a representation that's meant to simplify the system and enable subsequent prediction or explanation. It then asks for that explanation or prediction and asks the student to connect their explanation or prediction to the picture. If the item meets those criteria, we would then ask, when students are engaged in the explaining and predicting part of this practice, are they prompted to use fundamental disciplinary ideas like energy or bonding? And we do the same sort of thing with cross-cutting concepts as a third phase in this analysis. So what do these items look like? These are the only chemical structures. I don't know if that's good or bad in this whole talk. So you have a pair of phenomena. These are perhaps not very relatable phenomena, which we'll get to. But you can make the focal amide, that's this thing over here, a couple of different ways. You can start with an ester and an amine, that's A, so this is an ester, this is an amine, and you can do this reaction in methanol. You have to heat it and have to run it for a long time to get appreciable yields of product. In B, you can start with a different thing, an acid chloride, and now you can do this reaction in 2 hours at room temperature. We probably shouldn't be using dichloromethane as it is now banned by the EPA, but this was written before that. I'm sure it was perfectly fine for us then.
Maybe phenol too.
Yeah, that'll come back. So students are asked to construct a representation indicating the energy barrier to producing the tetrahedral intermediate shown over here in red, starting from the ester. If this is all we had, we would not consider this a three-dimensional prompt because we would have no idea why students drew that little squiggle. And so we subsequently asked students to explain why it requires more energy to produce the tetrahedral intermediate in system A relative to B, and in particular we want them to think about how the structure and relative energy of those reactant systems are different. So this is the kind of prompt I mean when I say a 3D prompt in this course. In terms of the percentage of points on exams that look like that, it's a decent chunk. So it's about a third on exam 1, a little more than that on exam 2, about half of exam 3, and 45% of exam 4. So what this means is to really succeed in this class, you had to connect fundamental ideas as to how and why chemical phenomena occur. In terms of what was going on in class, we recorded whole class meetings, and we saw that when thinking about a couple of different topic areas, this is one of the first reactions that we encounter in first semester, organic, and this is kind of midway through second semester, the instructor or the student were situating their dialogue in a phenomena and explaining how and why it happened using core ideas. If we look at interactivity using the COPUS on that same video data, we can see that there was a fair amount of interactivity, and overlap between the pink and the blue would suggest that it was the students who were connecting core ideas to predict, explain, and model phenomena. So I'm not going to really focus on content here. I will say the students in this class are pretty good at constructing normative explanations and models. I can show you that data later if you're interested in it, but that's not the point of this talk, because remember, epistemology is what we're interested in. Students are experiencing messages all the time about allowed ways to know and learn, where they're allowed to look for knowledge, what criteria they're able to use to justify an explanation or an argument or a model. These messages are embedded in instruction and the things that teachers say, and a lot of really great work has been done on messages embedded in teacher dialogue, including some great work by Christina, by Rosemary Russ, and several others. So an instructor might say that the best way to prepare for constructing authorized knowledge for course assessments is to try out causal accounts and get feedback on those causal accounts. Assessments themselves, both the structure of the assessment as well as the resources related to it, like answer keys, rubrics, and the like, those will send messages about allowed ways to know and learn. None of you can probably read this. However, I will posit that this is sending messages about the structure of allowed knowledge. You need to draw pictures here. You need to say particular words here. You've maybe seen those on answer keys, so you know roughly the structure of knowledge that will be acceptable in this place. Curricular materials also send messages about allowed ways to know and learn. So this is a slide from the first day of class. Memorization is an unreliable process to achieve the aim of understanding. That's what this is telling students. Over time, these messages can aggregate to powerfully inform the ways in which students engage in class tasks. So Christina showed this beautifully in a couple of contrasting enactments of a model-based unit in 4th or 5th grade? Fifth, okay. That paper literally changed my research direction, so thank you for that paper. And we see similar phenomena happening in the college space as you might expect. It turns out humans learn similarly, regardless how old they are. And so if we are looking to have students engage in ways of knowing and learning that are useful outside the classroom, we need to construct classes that signal the importance of those epistemologies. There's another element here. Instructors also have either tacit or explicit goals for what it should mean to know and learn in a place. We're going to talk about that in the second part of this talk, but that is not the focus of this part. The focus here is how students across the arc of a semester-long course experience messages related to knowing and learning embedded in or related to assessments, and how that shapes their engagement in assessment in the vocal course. So there's the research question. It's basically what I just said, so I'm not going to spend any time. How do we do that? Well, so assessment is a tricky context, because when students are engaging in assessments, they often do so quietly with a number 2 console and without talking to anybody. And so you can't stop them in the middle of their exam and go, what are you thinking? Why are you thinking it? Why did you write that? Where did that idea come from? They're going to fail their exam and be really pissed at you. And so instead what we did is we constructed interview protocols in which we pulled out epistemological messages we hypothesized might be consequential. And we had students reflect on how or whether they experienced those messages as they were navigating class, and what, if any, response to those messages occurred in their course of organic chemistry instruction. So we started out before students engaged with any course assessments. This was to give us a baseline for what they expected to be valued ways to know and learn in the focal class. And so we asked questions about what success looks like and where those criteria for success came from. It was often prior chemistry or STEM courses. We asked where they expected to get useful knowledge in the course and how they expected to connect it. We asked how they planned to approach preparing for course assessments. And then some even very early epistemological messages, such as that slide saying don't memorize, were built into this protocol so that students could experience those. And we could get a sense of how or whether, even early in the course, messages embedded in curriculum assessment or instruction shape student forms of engagement. The second interview was after students had taken a couple of midterm exams and a couple of quizzes, and now there are many more messages for us to play with when we're constructing our protocol. And so we would pull out course forum posts where instructors would, in this case, say something about reliable processes, and here the instructor is giving advice for constructing a causal account. My very, very favorite series of prompts that we designed was a series in which we took a practice exam prompt and we made sample student responses, and I'm using quotes because the research group made them, that were varied in principled ways. And so we would have one where there was a sort of a mechanistic account where we were thinking about lower scalar actors and their properties and how they interact to give rise to the phenomenon, but there's no jargon, as little jargon as possible. And then we'd have another one where you use all of the buzzwords, but it's just a description, but using lots of fancy words. And so in particular, when we ask students, do you think these responses provide convincing evidence that the person understood what the instructor was intending to assess, this was very successful in servicing students' perspectives on the criteria for good knowledge in the focal course, as you will see. And then finally, at the end, this is after students have engaged with most assessments in the course, so they would have acted on their epistemological understandings of useful knowledge and gotten feedback on their understandings a whole bunch of times. And so we had students reflect on their initial responses regarding things like where to go for knowledge at the beginning from interview 1 and at the end of the course. We thought about students' perspective on why instructors even give exams and whether those goals were likely to be useful in post-school life. And then we more granularly thought about the ideas and skills that seemed valuable in the course. These are, of course, nowhere near the full protocols. They're in that paper. I can share them with you. They were fun. What do we see? Well, first, of course, we need to talk about the analysis workflow. We interviewed 10 students, and we decided to reduce the data so we could delve more richly into the experiences of a smaller subset. And we did so by first asking each researcher who conducted these interviews to write a narrative memo about student experiences with knowing and learning in the focal course. And we selected 3 focal students that either represented many interviewed students with their responses or expressed an especially rich array of epistemologies, and these are them. So obviously names are pseudonyms. Lexi is a neurobiology major. That's our big sort of pre-med major at Wisconsin. Lexi is a pre-med. Lexi is here because she has to be. You have had Lexi in your class if you've taught any of these giant STEM courses. Ella is a chemistry major and intends to go to pharmacy school. Ella gave very sort of elaborated epistemic reflections. So she expressed an especially rich array of epistemologies. Sarah is who I would argue our course is made for. Sarah is a chemistry major. Sarah wants to make molecules when she leaves here. And so that's why she is part of our 3. We identified and described epistemological messaging segments by looking line by line through the transcripts of these interviews, and so we selected a transcript segment for further analysis if it related to student experiences with knowing and learning in the course, and suggested a source of epistemological messages that students were making sense of and or responding to. And we wrote analytical memos describing the source of the message, the content of the message, and how or whether that message was responded to. What does that actually look like? Here, the wording in the answer key is sending a consequential message about the structure of authorized knowledge. It has to have particular words in particular places. Well, what do you do as a result of making sense of that message? Well, you memorize the key. That's totally sensible. That too will come back. We then identified patterns in the epistemological messaging segments, first within the arc of one student's experience in the course and then across students. And the 2 finding types that we came up with were first that the aims, the goals, animating knowledge construction, and the criteria by which aims were achieved, those were homogenized across our 3 students, and reliable processes were compiled differently as these students navigated the course. I'm going to focus on this one because I think it's more germane to our useful and daily life conversation. When I say conversation, it's more of a monologue because I'm just sort of talking. So what do we find? Unsurprisingly to all of you, I think, students enter our courses planning to do whatever it is we ask them to do to survive, right? So Ella literally said, I will understand whatever the hell the professor of TS is telling me about. It's all fine. I'm here for it. I'm at a flagship institution because I'm good at this sort of thing. And assessments are there to sort of prove that you can do that, right? Instead of earning quote unquote free credit. So what sorts of things do they want you to do? Well, Sarah said they want you to put buzzwords in sentences. And what's interesting about this quote is Sarah ends by saying, we're going to be having explaining questions. But I don't think she means explaining in the way that you or I might be explaining. I think she means explaining as in you're going to be writing sentences and they're going to have buzzwords. The fact that maybe these should have some connection to the observable world and seem like a sensible causal account that underpins something you see, maybe that's not so important. Also, just a moment, it's coming. And so now we're at the midpoint where students have engaged with course assessments and gotten feedback of their epistemic understandings of the course. Ella says this sort of really reflective but also really sad to someone who teaches this course bit of prose. And she here distinguishes between a real scientific explanation. In a real scientific explanation, you need to talk about electrons being donated from this orbital to that orbital. That's the thing. And that's important for this class or exam. But if I'm like just explaining stuff to my friends, then I can talk about things wanting other things. Like it just has to make sense to us, and then we can like move forward. This was elicited by a course forum post in which an instructor says, you must not use attack or want, you must use donating, or else. And this is what Ella responds. So clearly, Ella has a diverse set of epistemic resources that she could be connecting to make sense of phenomena in this focal course. But we're constraining her. She sees that she is only authorized to construct a buzzword-laden real scientific explanation. So this then gets ported over to when we ask her about whether she could engage with a new phenomenon and construct a reasonable causal account. Ella says, yeah, I could construct a reasonable causal account. I could make sense of this chemically in a way that seems like it makes sense to me. But I'm going to have a really hard time predicting which buzzwords need to be included and where they need to be. And so I'm not sure I can do what they're looking for. This is rough when you're one of them. I just want to acknowledge that. What are they looking for? Again, buzzword, it's buzzword bigger, right? They're looking for buzzwords and sentences. So Lexi encounters a question type where every single time she sees a question that looks like this, hyperconjugation gets points, and she keeps missing the points, and it's maddening. And so, what does she do? She sees a question that looks kind of like that, and she just writes down hyperconjugation. And then she built a sentence around it. That's the key. This is hyperconjugation. Right there, look, it's underlined, it has 1 point. Do it, put it in a sentence, go. It's go time. You better know what the little, like, fun-looking circle is, too. We don't see much change in ideals and aims as we look across interviews 2 and 3. And so because the sort of knowledge construction we do in this space is try to read the mind of the person who wrote the answer key and write that, it's kind of frustrating when you like draw something that you think kind of matches the key and yet you still lose points. It doesn't really make sense because of the constraints we've placed on you about the sort of knowledge construction you're allowed to partake in. Kind of echoing what Ella was saying in the last interview, Sarah would know what happens and know why, but would leave out a buzzword, and so would lose points. And this is reinforcing this idea that A, good knowledge is a very particular structure, and B, you have no say in that structure. You've got to just predict what the person who wrote the key is going to put down. So in summary, students' goals for knowledge construction and the criteria by which those are achieved, those get railroaded pretty early on. Instructor-authored keys are a really, really consequential source of epistemological messages in this course, and that is sensible. You are in this course probably because you need to be, so you can like be a dentist, and you want to survive and get an A. Knowledge is justified by aligning with these keys, and whether it makes sense to you is sort of irrelevant. Like it would be nice. It's a nice to have. It'd be great if it made sense, but it's not necessary. And as I've said a few times, authorized knowledge must have a very particular structure. So, I don't know about you, but since I've left school, I have rarely needed to like be in a room with a number 2 pencil and write a sentence with inscrutably picked buzzwords and then hand it to somebody and have them like put -2 on it. Like that has not happened in my daily life. These epistemologies in their constrained nature are not approximating situations we are likely to encounter when we leave the classroom. So we, those of us who built this reform course, of which I am one, are not